Let's start on time. We have 40 minutes to go, even if it's the last regular session of the day here. Hi, everybody. Welcome to the last session in the Cloud and Microservices track. I admit this is a bit of a stretch. This is largely a Spring Framework programming model discussion. We are not going to refer to the cloud or microservices very explicitly, although I am going to make a few connections. This is the underpinning. This is the model that, this is about the annotated programming model that Spring Boot and Spring Cloud are based on. And I'm using the opportunity to talk about not only the state of the art, but actually the state of the art as of Spring Framework 4.3, which is forthcoming. 4.3 RC1 is scheduled for March. So we are a little bit ahead of the time. It's only the second time I'm talking about 4.3 at all. The first time was at Vox Days Berlin last week. So we're a little bit ahead of ourselves. I'm going to make statements about what's in 4.3 along the lines. However, during the presentation and during the flow of the presentation, it's not actually that relevant where and when things have been introduced. We are going to look at the Spring Framework programming model from a design perspective with kind of a general 4.x state-of-the-art mindset. It doesn't really matter whether things have been introduced in 4.1, 4.2, or 4.3, but for the sake of the forward-looking note here I'm going to highlight the bits that are new in 4.3. So, quick poll. Who's been working with Spring before? I guess pretty much everybody. Inverse question. Who has not been working with Spring at all yet? Or not, who doesn't have much exposure yet, right? That kind of. All right, that's, there's a clear majority, but I hope it's easy enough to follow even without deeper Spring exposure before. So let's get right into it. This is, by the way, basically all source code. So if you've been seeing any presentations of mine lately, they are basically exclusively source code on slides. I'm not going to do live demos because we're going to do a design review, and you've seen a boot demo in this track already today. So we're largely going to look at bits of source code and the style that source code is using, right? The enrichment of the Java language that is what we're calling the Spring programming model. All right, so the core element of everything we're doing in Spring Land is basically a Java class. An annotated Java class in this particular case. It doesn't necessarily have to be annotated. It can also be enriched with metadata externally, which is what Spring calls a bean definition, but it doesn't really matter for the sake of this talk. It's about the annotated model. So we have a Java class, just a regular Java class implementing a regular Java interface, using constructors, using methods, right? You're really not being constrained. Part of the Spring programming philosophy is that you're using the Java language in its natural and idiomatic fashion and just selectively adding certain elements of metadata, certain descriptive elements, in this particular case through annotations, that allow the framework to react to your class at runtime. But there's always a source level perspective to take. So at the moment, let's forget about the runtime. Let's just look at the class. It's a class that's annotated with a service annotation on top, so a stereotype. Pretty much like UML stereotypes, you could say this is a repository, at repository, it has a controller role, at controller, or in this particular case, at service, kind of a generic stereotype in between. These kinds of stereotypes are not names, they are formal annotations, so any code living in the same system, including the framework itself, can react to the formal presence of that annotation. So it's more formal than the name, right? It's called my book admin service. Does this actually do anything? We have a pointer here. Anyway, the formal notion makes a difference. because instead of just checking the names, we can actually check for the presence of annotations. And it also makes a difference in readability and in the usability of those elements, right? So it's a good idea to also reflect the role in the name, but the formal element is more important for our purposes. We have an annotated, we have a potentially annotated constructor, and we have an annotated service method, public service method here. The constructor is already worth discussing as a new bit. It's about a constructor that needs to be dependency injected. It takes an account repository. If we intend to construct a MyBookAdmin service, we need to provide an account repository object to inject. And at runtime, that's typically the framework's job, except for unit tests where you could inject a mock directly through a constructor call. In traditional Spring, we used to insist on the presence of an auto-wired constructor, an auto-wired annotation at the constructor level, simply because the explicitness is actually worth it, and I would still argue it's worth it. So in this particular case, where you have type-level annotations, where you have service-level annotations, it's usually a good idea to be explicit about your injection points, to annotate the fields, to annotate the methods, the setter methods, or the constructors that you want the framework to call, that are basically designed for auto-wiring purposes. However, in 4.3, based on a lot of demand, we have a fallback assumption if there's only one constructor in any given class, and we have no more explicit metadata given, then we assume that this constructor is meant to be auto-wired instead of failing. Right? Previously, Spring would have said, like, there is no default constructor, and I'm not being told to auto-wire anything, so I'm failing. But we made this a little bit smarter, or you could say a little bit more lenient in just choosing the constructor that's been given. That's particularly interesting for classes that are otherwise not annotated at all. Take simple repository implementations, simple delegates within your source code arrangement. They might not be a transactional boundary, require a transactional boundary, or any kind of special qualities. They just use dependency injection. And in particular for those cases, it's nice to not have to annotate the constructor. By the way, that's entirely possible already, right? You could just flip the auto-wire by type mode to auto-wire constructor in your external configuration of that bean, and you would get exactly the same behavior. The point is, we're doing that by default now if there's no better way to construct the object. So any annotation that you see commented out in this presentation is basically optional. It's semantically there, right? It should be there for explicitness, but it doesn't have to be there because it's the default behavior. All right, transactional boundaries, I suppose you guys know this, is of course descriptive but has a strong runtime meaning. The transactional boundary is the method's execution scope, but the point of this slide is it's a descriptive element. We're saying the method is transactional. The constructor is auto-wired. The class MyBookAdmin service is a lazy service. You have to jump around a little, but you can read it. It's basically descriptive. You can turn it into a sentence, into an English language sentence. That's the whole point of the names chosen for those annotations. And it's the primary perspective to take when you look at source code that's annotated like that. Of course, at runtime, we react to those things. We choose the constructor automatically. We auto-wire it with a repository. We start transactions. Before we enter the method, we commit or roll back at the end. But that's runtime behavior. Both perspectives are important. And the source level perspective is often forgotten. So it's not all about the runtime. A couple of details on the annotation model. It's a bit of a personal selection of highlights in the Spring Framework 4 component model, you could argue. So I'm not trying to be comprehensive, but I'm trying to focus on the most important stuff, or the stuff that, from my perspective, isn't really understood as much as it should, or is not as popular as much as it should be. Anyway, so annotations can be composed. You can create your own. And your own can be meta-annotated with standard Spring annotations. So this custom MyService annotation at interface is just a Java annotation declaration, nothing fancy really. And it's meta-annotated with a combination of Spring characteristics. So this custom MyService inherits the characteristics of a standard Spring Add service. It has a different default scope, not singleton as usual, but switch to session here. It has a default primary characteristic. Primary, in all brevity, just means in case there's more than one of these, for any given injection point, this one always wins. So if there's more than one type match, this one overrides any other type match. A nice alternative to using qualifiers. And it even has default transactional characteristics. So by default, the specified transactional behavior on all external public service invocations on an instance of this class. Right, anytime you're saying MyService, add MyService on any class of yours, what you're actually saying is the combination of characteristics above. This feature is heavily used in a lot of the infrastructure that we're providing around the Spring Framework these days. In Spring Boot for a start, in Spring Cloud even more. So a lot of the configuration magic or the semantic magic that you're seeing in Spring Boot and Spring Cloud actually follows from this core principle. Composed annotations. Add Spring Cloud, add Spring Boot application, add Spring Cloud application are just pre-composed annotations that share a lot of characteristics as meta annotations. You can have a look at them. Just look at what the Spring Boot application or Spring Cloud application declarations say. So those are just pre-composed for your convenience. You can create your own. So it's, of course, a kind of shortcutting model here. And it's again about names. Please, anytime you're doing stuff like this, choose a meaningful name for those annotations that you're creating. Don't call them at MyService. I intentionally try to create a silly name here for you not to repeat it. So MyService, I'm using the my prefix all the time, has no meaning other than for my examples. In your world, in your code bases, please choose a meaningful name. Order service, account service, reconciliation service, something that has a meaning in your domain, in your architecture, in your code base structure. And then it's even nicer. It's a descriptive element that tells you something about the type of this class. It tells you a little bit more than just class, right? Just the Java language keyword. It gives you a hint at the role that this class is having, and it's also a nice carrier of formal characteristics as shown above. Composable annotations can have attributes as of Spring Framework 4.0, and as of 4.2 they can even be very explicit in what they are referring to. So just two examples for stuff you can do. Keep in mind, it works for almost any annotation in Spring at the moment. Almost any is, we're about to close the gaps actually. In Spring Framework 4.3, it's going to be possible for any annotation where it makes technical sense. We're almost there, but there are a few exceptions, at JMS Listener, for example. But for almost other annotations, you can actually compose them. For example, this is a custom scoping annotation. It says I'm a scoping annotation, meta-annotated with scope session. I have the name my session scoped, and I redeclare an attribute called mode. So it's a custom scoping annotation with a hard-coded scope name, which isn't actually the point here. You are not up for choosing your custom textual scope name. It's hardwired for you, no mistake to make there. And in this particular case, the scoped proxy mode in Spring is exposed to the user of your annotation through a redeclaration of that attribute. But it's your choice to do that. If you do not provide any attributes here, it's all hard-coded. No choice for the user of your annotation anymore, which can be intentional. It's about guidance. Do you want the users of your annotations to influence some of those things or not? So scope proxy mode in this particular case is redeclared and is actually using the default proxy mode no, but that's the other feature here. You may choose a different default. Any annotation attribute can declare a default. That default may be different from Spring's default in the add scope annotation. And for explicitness, it's again about readability. This redeclaration actually explicitly points to the scope class. So it says, I'm an alias for the proxy mode attribute in the scope annotation. It's very explicit. It's even, you can basically navigate there. And in IntelliJ IDEA, it even understands the attribute reference. The most subtle feature in this context is the renaming. This attribute is called mode, but it refers to the attribute named proxy mode in the scope annotation. So you can choose to change the name, to use a different terminology, or just to shorten them. Right, and the transaction annotation down here, another example, a custom transaction annotation to be used instead of @transactional, has an alias for the same named attribute on the transactional class. If there's no attribute given, then it's assumably the same name. So we only redeclare the read-only attribute from @transactional, which implies we ignore all the others. No propagation mode, no timeout, no isolation level, no rollback rules. They are all hard-coded. So the user of your custom annotation can only influence the read-only declaration. That's very intentional. It's, again, guiding, right? Care about this attribute. Forget about the other characteristics. You're not supposed to change them. And even further, there's no declaration of a default here. Just look at the difference here. No default declaration in the Java language means that the attribute has to be set. Any user of your custom annotation has to set read-only equals true or read-only equals false. You can't get away without setting some value. And this is intentional here. It's about forcing the user of your annotation to reason about the read-only status. You can't forget about making that decision explicitly. So there's quite a bit of design power in this rather simple composition model. And the examples given are just highlighting a few of the things that you can do. And many of those things are being done in a quite extreme fashion in Spring Boot and Spring Cloud, in case you want to understand how those frameworks work. Right, for the 3 nodes, we actually do not provide out-of-the-box annotations for the web scopes yet. We leave that up to you. You can build your own, like shown before. It's commonly requested that we should ship out-of-the-box annotations that just say @request scope, meta annotated with @scope, and ideally pre-proxied for target class. That's up for discussion at this point still. There's a couple of such annotations around already in other Spring projects. Step scope and job scope come from Spring Batch. Refresh scope comes from Spring Cloud. They are all just pre-composed scoping annotations. They actually just refer to a named scope, but they are nicer to use and a little bit limiting, which is intentional here, right? You can't just freely change or mistype the scope name. So for the 3, we intend to have out-of-the-box declarations for our 3 web scopes, just for those. So request scope, session scope, and application scope would get an out-of-the-box annotation. The scopes, of course, already exist. There are already scopes named request, session, and application. It's really just about the convenience annotations to refer to them, for consistency with Spring Cloud and Spring Batch in particular. So a quick note or a little bit of a discussion on the basics of configuration classes, and I'm going to show you a few, well, maybe less well-known variants of configuration classes in just a bit. The basic configuration class arrangement is omnipresent. I mean, basically Spring Boot is primarily a collection of pre-built configuration classes and @enable annotations. At its core, the configuration class is an element of the Spring programming model. So it's just a regular Java class, kind of regular, right? It's annotated with @configuration. So instead of saying this is a service or this is a repository, you say this is a configuration class. At runtime, Spring is going to manage an instance of this class. So it's actually a regular instance. It can have fields, it can share state in fields, and its special characteristic is that it's actually a holder for @bean methods, for factory methods. So a configuration class is not particularly special. It's a regular Spring component class, regularly managed in terms of its life cycle, but the container inspects @bean methods and derives additional bean definitions from this class. So it's a bean itself, but it in particular has the job of declaring other beans. And in a configuration class-centric architecture, like in Spring Boot, almost all the beans are declared through @bean methods. There can be any number of configuration classes with any number of @bean methods on them. So it's up to you or up to Spring Boot to choose its granularity and choose its combination of @bean methods. @enable annotations are basically a variant of this. They are convenient shortcuts, composable shortcuts for activating certain framework functionality. So @enable transaction management up there is just an example. There are many others in Spring Boot and in particular in Spring Cloud. So they are opt-in declarations for certain framework functionality. The design background here is that in Spring's philosophy, it's a what you design is what you get, or what you define is what you get. So we don't activate richer, more side effect prone framework functionality by default. You opt in, right? You choose to enable transaction management. You choose to enable a Eureka server, right? It's your choice. It's a one-line explicit declaration once in your configuration, which makes it easy to opt out. Just don't declare that annotation. You will not get transactional interception at runtime. It's your choice to ignore certain framework features. So you can have @transaction annotations, but as long as you don't enable transaction management, those are just descriptive. The framework does not react to them. It only reacts to them if you also specify transaction management and manager bean and @enable transaction management to flag it in and make the combination. So it's at the same time convenient and explicit. Right, @bean methods, remember, are factory methods, not lookup methods. So for scoped beans, the container is going to call them every time it needs to create a new instance. The instances are then going to be cached and reused within their scope. So you're only going to see one invocation per scope. Doesn't make a difference for a singleton bean really, but if you have a session scoped bean here, you're only going to see an invocation of this method for every session where this bean is actually requested within. So it's lazily created and put into each session. A special feature here is this reference. Looks innocent, but it's actually somewhat tricky. This bookadmin data source call is not a regular method call. It's a symbolic reference to this other bean. The container will at runtime create a subclass of this class, intercept calls to this method, and find out that what you really mean here is a reference to the current instance of that bean. So this call actually goes back out to the container. The container may reuse an existing instance. If it needs a new instance, the call comes back into the actual bookadmin data source method. So this call is actually intercepted as a symbolic reference to the current instance of that other bean. Reusing singleton instances, respecting scoping, potentially creating a proxy of that bean, all the functionality applied. Right, now let's look at a few variants that you might not have seen. This is basically the same arrangement, but instead of pointing to another method as a symbolic reference to some other bean that you need, which was the data source bean before, right? You are now requesting a reference to such a bean through an argument. @bean methods can have arguments, which just suggests to the container, a little bit like with constructors, to please inject a bean that's assignable to data source, respecting all the qualifier and primary handling and so forth. So you get a reference into the methods. Alternatively, it's often seen that there are auto-wired fields, that a configuration class has field declarations that are auto-wired. So auto-wired bookadmin data source on a field, but that's not really so recommendable. This allows the container to lazily create the data source and to always provide a currently scoped instance of the data source if that's ever needed. So that's a auto-varying provided two factory methods through just method arguments. And of course, you can also do constructors. The of course part needs to be de-emphasized a little because it only really works as of 4.3. Previously, configuration classes could have constructors, but through the cglib subclassing, it wasn't actually easy to make it auto-wired. It was doable, but not straightforward. These days, as of 4.3, you can just declare a constructor like on any other component class, make it accept the type that you need, the object that you need, the dependency that you need injected, and just store it in an instance variable if you know that it's according to its scope, if that's doable, right? If it's a singleton bean, then you can, of course, do this, and then just refer to the instance variable. So a little bit like the field injection case that I hinted at, but now done through the constructor. There is a difference here. This is a construction time, instantiation time injection point, right? So the configuration class is being instantiated, receives that object, stores it in a field and reuses it. So you're not reobtaining a scoped bean here. You share a reference to a reusable bean. So there's an assumption here. Data source basically needs to have the same scope as this configuration class, which for practical purposes means it needs to be a singleton. All right. Configuration classes are regular Java classes. Proving that point, you can use inheritance. And you're seeing quite a bit of this in Spring Boot and Spring Cloud as well. The extends clause just does what you think it does, right? It splits a class into a base class and a subclass in this particular case. It's only really a sketch anyway. And the algorithm that detects adbean methods, of course, finds adbean declarations in superclasses. So we find adbean methods across the entire class hierarchy, which is a really nice feature. It allows you to build base configuration arrangements where certain beans can be overridden in custom subclasses. You could create abstract configuration fragments where the abstract methods are being substituted in the subclass. That's actually a feature that we use internally quite a bit across the portfolio, abstract configuration fragments and substituted in for certain use cases within the frameworks. So quite a bit of power, basically the same power that you have with standard Java inheritance in your own classes. You can apply it to configuration classes as well, because they are essentially regular Java classes. And taking that principle to its next step, we even support Java 8 default methods along those lines. Not sure you ever tried this or you even thought about trying it, but what if a configuration class implements an interface? It's a Java class, can implement any Java interface. And if that Java interface happens to have default methods with a body, possible as of Java 8, right? And those default methods are annotated with adbean. What should we do with those? Well, we actually do what we need to do. We find them and we register them. It actually works. You can compose configuration classes from configuration interface fragments. There's even multiple inheritance possible. You can implement more than one interface and you share the default adbean declarations from all of those interfaces. And you can still override them in the concrete class according to Java 8 default method rules. We're not changing the semantics of the default keyword and interfaces here. We are just making it work before we actually ignored it, right? So we didn't find those methods, which is a little strange if you annotate them and they're not being found at runtime. It's up for discussion whether this is a particularly good idea to compose configuration classes like that. From my perspective, this follows from the basic design principle in Spring. Java language semantics and enhanced with annotations. The outcome needs to be straightforwardly derived from those basic principles. And this totally makes sense from that perspective. Right, just a side note, since I mentioned cglib subclasses before. In case you mind cglib, you know, these generated subclass that finds out about the method calls that you do within the class. You can just skip that by not declaring add configuration. This behavior is tied to the configuration stereotype. If you just choose any other stereotype, if you say add component up there, or any other stereotype that's not add configuration, you will still get configuration class-like behavior. We find the add bean methods, we register the bean definitions for the add bean methods, but we do not generate the subclass. Cross method calls are just that, a direct method call. That may make sense in some scenarios, and it's in particular useful to know if in any given environment you can't use CGLib. All right. A different topic of focus for today, the injection point matching algorithm. I'm sure you've seen, several kinds of injection points, but how do we actually process them? So injection points, as a basic definition, we mean the declaration of an argument that's about to be injected, supposed to be injected, for example, a construct argument, a method argument, or a field, if the field is marked as auto-wired. So in this particular case, let's look at a few interesting kinds of injection points. This injection point says, I want a my repository of account. This used to not matter. In Spring Framework before 4.0, we basically just ignored that part. We always just looked at the primary type, my repository, and we just found out about any matching bean that's assignable to my repository. If there was more than one, we would just fail with a non-unique exception, unless you used qualifiers or the primary flag or some other hint that makes a clear connection to one of the beans. But as of Spring Framework 4.0, we're trying to address a scenario like this. There might be add bean declarations in some other configuration class. One that says I declare a my repository of account, the other says my repository of product. And the injection point clearly says my repository of account. In Spring Framework 3.0, you would nevertheless, 3.2 still, you would nevertheless get a non-unique exception based on the old rules. As of 4.0, there's a completely new implementation of the matching algorithm that takes the full type declaration, even generic type information down to any level, into account. So we take the entire generic declaration and we choose a bean that's assignable to this declaration according to the Java language generic type matching rules. It basically means if the compiler would accept it as an assignment, then we consider it a match. So we actually do pick we do the obvious, right? We pick the my repository account declaration and inject it. We're not going to mix it up with the other one. Without any qualifiers, no extra annotations needed, no primary flag needed, just based on the type declaration. The idea again is to use the Java language declaration to the best possible degree. And if the type declaration is rich enough, we do not insist on extra metadata. This works in many scenarios, but due to type erasure, we can't do it in every scenario. So if this declaration just says object or my repository, but not of account or product, we can't actually figure out these type declaration from an instance. However, we can figure it out from a signature. So as long as this information is in a method signature, or in a method return type declaration, or in an extends declaration, or an implements declaration, we are able to find out about it. Type erasure in Java just happens against instances, not against declarations. It's a little hard to find out about it at runtime, but it does work, and we do take it into account. So as long as the information is here, or in the implementation class of what's returned here, maybe there could be a my repository impl that says implements my repository of product. If it says so in its implements declaration, that's okay. But even more powerful, we do take the add bean method return type, return signature into account here, which makes it a very obvious match. All right, just variants of this. You can request all matching beans of a given declaration. you can say, I want a list of my repository of account. And what we're going to do is, we basically say like list suggests you want all of those my repository of account. So we're going to look for my repository of account declarations. We find 2. We build a list from it. We even pre-order it if there are order declarations. And we inject the resulting list. So, which is already 3-level nesting here, right, of generic type declarations. So that's injection of all matching beans, not of a single matching bean, potentially in a pre-ordered fashion. As of for the 3, based on common requests, we also allow for this arrangement where we say like a list of account, for example, based on the previous rules, that would mean a list of account beans. What if there is no list of account beans, if there are no account beans, if that's not what you meant? But if you rather meant to point to a bean that's itself declared as a list of account like above, we allow for that now in Fodder 3, as long as the type information is sufficiently expressive. Keep in mind that type erasure usually hits you hard, in particular for collections. So we need to have that information somewhere. If you just return a generic list up there, a general list without account, right? And you build some array list and there are just account instances in there, we don't know about that. We only know about generic type information that comes from signatures. So this is particularly meant to work with @bean methods that have a very explicit declaration, such as the one shown here. So that's a variant that's actually new in Fodder 3. This has been around for a little bit longer. Lazy declarations, a combination of a type declaration, says my repository of account, but a parameter level annotation says I want a lazy my repository of account. That's a pretty important semantic piece that we're adding here. Laziness in Spring terminology allows us to inject a proxy that's not really fully initialized yet. When a method call comes in on the proxy later on, we are going to initialize to make sure that the bean is initialized then and only then. From a readability perspective, you're basically saying, I don't really need this object to work right now. I want a reference to it, but I'm just going to store it in some field, which is very common in constructors, and I'm going to use it later on when some method invocations come in, some service methods are being called. If you're using it in the constructor itself, right, then lazy is basically pointless. It only makes sense if it semantically means you're not going to use it right away. This is a nice way to break cycles, for example. A cyclic definition, a circular definition from A to B and B to A, both through the constructor, is unresolvable. We can't create one without the other, except if one of the beans says that it only lazily needs the other. Then it's clear how to resolve it. If both say it's lazy, even better. So laziness is quite important, can be quite important in more complex arrangements, and actually Spring Boot makes heavy use of laziness as well. The lazy declaration at the bean level, up there, is semantically different, but generally a good idea to go with the other. Laziness for a given bean definition means that we are not eagerly creating instances of it. In particular for singleton beans, we are not going to pre-instantiate it on startup. We are only going to instantiate it when it's actually needed, when it's actually requested. So laziness at the injection point or laziness at the bean definition point. Both of them together make a lot of sense in some scenarios. Right, just for the sake of showcasing what's possible, a variant of it that does not have Spring imports. You're not going to see much of that in Spring Boot, but it's technically possible out of the box by default without extra configuration by saying this class here has javax.annotation.managedBean as a stereotype, very simple, non-composable, but it does the job of identifying the class. It even works with component scanning. So the good old Spring component scanning mechanism, going through some base package, actually finds out about those. And it's not just the bean declaration, it's in particular the injection point. Add inject says, basically an injection point, right? Like at AutoWired, following the same rules. And that's a destroy method, also coming from javax.annotation, not important for today. Now look at that signature. This one says, I want a provider, that's a javax.inject.provider, of my repository of account. That actually expresses lazy access. It's another way of expressing a lazy reference. Provider has a get method. So all you receive here in standard javax.inject rules is a handle, a provider, which whenever you call get on it, will retrieve the current instance of the target bean. Instead of generating a proxy, you have basically this little decorator interface provider with its get method. And no Spring imports needed. None of those concepts is Spring specific. Just in case. All right, we're already moving towards the bonus section of the talk. Just in case you wondered, Java 8 has Java util optional. What happens if you declare an injection point as optional? That's Java util optional as in Java 8, right? Optional of my repository of account. We actually take that into account. So we find out whether there is a matching bean. If there is one, you get it wrapped in an optional handle, where you can react to its presence or non-presence. If it's not there, we're going to inject optional empty. And based on the Java util optional API, the implementation of the constructor can then kind of set itself up based on the presence or non-presence. In Spring's at AutoWide, you could just say required false and get a null reference. But in the JavaX inject world, there is no required flag. The only way to express optionality is through using optional. It's actually somewhat common these days. Quite a few people do this. Not only for injection points, also for Spring MVC handler method arguments and the like. But it's again in the signature, right? 3-level generic type declaration that the framework understands here. Right, well, so much for this really, for the injection point discussion. Very quick note, the Spring formatting annotations on types. You don't have to add that sort of stuff if it semantically follows from the type declaration. So this one is commented out again because at datetime format, ISO date is actually the default behavior. We understand that this is a Java 8 Java time local date. We have a default ISO date representation against that type anyway. So you can add that kind of formatting information, but you don't have to. Only if it deviates from the default representation. Works both for java.time and for jo.time. So just make sure that you're not overusing some of those annotations. It's kind of a theme in recent Spring, in Spring's recent evolution to not require annotations if their semantics follow from the type declaration anyway. All right, so to wrap this up, it's not the focus of today's talk, and I suppose you know some of the endpoint models, right? That's a Spring MVC endpoint class with mapping annotation, handler methods, and so forth. Here maybe this an object like before with formatting and validation annotations inside, right? That sort of stuff. You can actually declare those things as optional, by the way. You could wrap this in an optional long. But just to wrap up this talk, this is a standard controller declaration, right? With a controller stereotype and standard mappings. As of 4.3, we intend, it's not there yet, we intend to provide pre-composed annotations for get, post, patch, put, and delete. Just pre-composed. You can do this yourself, right? Declare your own get mapping annotation, meta-annotate it with that request mapping, and you're done. The pre-composed ones are just very commonly requested, and it's a bit of a design discussion going on in the team at the moment, whether that's worth having. If you compare it to the previous example, the primary difference is that there's only one attribute. And if you only have one attribute, you can use the value mechanism in the Java language, which means you don't have to specify an attribute name. So instead of saying path equals and method equals up there, this get mapping turns into a nicer one attribute annotation. That's generally always worth allowing for, because the get information, the HTTP method, sticks in the annotation types themselves. So that's actually technically very simple. Just much requested to ship this out of the box and to have it in the examples and in the sample apps. So chances at the moment look like we are going to do this for 4.3. but it's not in the snapshots yet. And there's already a case up there at REST controller, which is already around since 4.0 and does the same thing. It's a combination of at controller and at response body, which influences the behavior of the handler method if you return an object. So we already have cases in Spring Web MVC where we compose annotations. We are basically just also doing it out of the box for some convenience mapping annotations now. Just to give you an idea of how far we are taking our own composability feature. All right, well, the point of the remaining 3 slides here is mapping annotations always look the same way. In Spring land, whether it's an HTTP mapping, like in our cases before, right? HTTP endpoint potentially running in a servlet container, or whether it's stomp message endpoint on a WebSocket channel, don't care about the details. Just look at the syntactical impression, right? At the stylistic impression. Looks very, very similar. You're not mapping against HTTP requests, but against a stomp subscribe message or a regular stomp message. And that's the style that we're using to represent such endpoints. And you can do the same, for example, for JMS listeners. So JMS listener declarations, they potentially have plenty of attributes if you want to fine-tune them, but in the simplest possible case, they are very straightforward and pretty analogous to what you know as Spring MVC handler methods. So we are using the same design philosophy for many endpoint models in Spring. For example, in 4.2, that's Spring application event listeners, heavily used in some scenarios. They use the same style. Annotated callback methods, annotated with @event listener, and flexible method declarations, as you're used to from Spring MVC. So the design philosophy is not just about the core programming model, it's also about the wider endpoint models in the Spring portfolio. All right. I've already mentioned that for the 3 RC1 is scheduled for March 2016, and for the 3GA is scheduled for May. Those are already pretty hard dates. I mean, mid-March is actually not far away, so we are busily finalizing RC1 at the moment, and it's going to go GA in early May, in time for the Spring I/O conference in Barcelona. We tend to do conference-driven releases for our own conferences. The 4.3 is going to be the last Spring Framework 4.x feature release. There's not going to be a 4.4. The next thing we're working on is Spring Framework 5.0 coming in early 2017 with a strong JDK 9 theme and a strong focus on reactive programming. These are here just system requirements because if you care, about JDK 6 and 7 and all the servlet containers and so forth, stay on 4.3. 4.3 is going to do its job for you up until 2020. It's going to have an extended support life similar to Spring Framework 3.2 at the moment, which has a pretty long support life already, but it's going to be end of life at the end of 2016. This one is going to be, according to the current plan, supported until 2020 with 4.3.x maintenance releases, and no changes in the system requirements. Still supporting JDK 6 and 7, potentially very much 8, and potentially even 9. We will at least have basic JDK 9 support even in that line, whereas Spring Framework 5 is already designed to be JDK 8+ for many reasons. And we're talking about early 2017. JDK 8 is then 3 years old, so we really need a generation of the framework that's internally also based on JDK 8, not just externally supporting JDK 8 in your own components. Basically, at this point, you guys can use so much JDK 8 greatness in your code, but we can't use it in ours. And as of Spring Framework 5, at least we cannot have hard references in our code, right? We only do it reflectively and conditionally. Whereas in Spring Framework 5, we can finally fine-tune our own code base, use lambdas internally, use default method declarations internally, that sort of stuff. That really makes a difference as a forward-looking measure to allow to clean up the code base and allow for further evolution in Spring Framework 5.1, 5.2, and so forth. All right, thanks for your attention. I guess this was a little bit over time. I hope you don't mind. Give maybe Spring Framework for the 3 snapshots even a try, but in particular the release candidates as they come out in March and April. And well, of course, if you're not quite there yet, I would highly recommend upgrading to the latest Spring Framework 4.2 release. 4.2.4 at the moment. We are going to release 4.2.5 in about 2 weeks. So if you stay on the latest there, you're well prepared, and for the 3 is going to be an easy upgrade coming in just a few months. So thanks for your attention. If there's any questions not answered during the presentation itself, I tried to anticipate a few. Just drop them my way. I'm around anyway, and I'm not actually sure when the evening keynote starts. 7:30. Yeah, in 10 minutes. Yeah. So if there are any remaining questions, I'm happy to answer them. But I would say come up front to the stage. Let's do it individually. Thanks.